Have you ever stopped to wonder how your phone is actually going to run the next wave of powerful AI? Well, you've come to the right place. Today, we're diving deep into Google's huge update for on-device artificial intelligence, a universal framework they're calling LiteRT. So here's the plan. We'll kick things off with the big challenge developers have been facing. Then we'll introduce LiteRT as the answer and see how it cranks up hardware acceleration. After that, we'll get into the really cool stuff, how it unlocks generative AI right on your device, how it's all built on a foundation you can trust, and finally, what you need to get started. All right, so let's set the stage. The dream is to have really sophisticated AI running right on our devices, our phones, our tablets, you name it. But for the people actually building this stuff, the developers, getting there has been, well, a total nightmare.
And it all really boils down to this single question. Why is it so ridiculously hard to get a powerful AI model to work smoothly right in the palm of your hand? The short answer is one word: fragmentation.
For a developer, it's seriously like trying to navigate a maze in the dark. You've got hundreds of different system-on-a-chip variants, the SoCs. Each one has its own weird compilers and runtimes. This mess leads to these super complex, custom-built workflows just to get an app out the door. And maybe the biggest problem of all, a real lack of deep integration with the hardware that's actually designed for AI, the neural processing units, or NPUs.
So how in the world do you find your way out of that maze? Well, this is exactly where LiteRT steps in. Google is positioning this as the unified solution to that whole fragmentation problem. So what is LiteRT exactly? Simply put, it's a universal framework for on-device AI. It takes that solid, trusted foundation of TensorFlow Lite and basically gives it a massive upgrade for the kind of cutting-edge models that everyone wants to use today. And it comes with 4 huge promises. It's going to be faster than what we had before. It's going to be simpler for developers to actually use. It's powerful enough to run real generative AI. And it's flexible enough to work with the tools developers already know and love. Let's see if it actually delivers on all that. First up, performance. Because let's be honest, a framework is only as good as the speed it can deliver. And this is where LiteRT really starts to flex its muscles by unlocking the specialized hardware that's probably already sitting in your pocket.
And this quote right here just nails it. Your CPU and GPU are great all-rounders, but the NPU, that neural processing unit, that is the specialized key you need for that snappy, high-speed, truly responsive AI experience.
Now take a look at this, because the scale of this performance jump is just wild. If you think of the CPU as your starting point, your baseline, the GPU can already give you a nice 10x speedup. But look at the NPU. We are talking about a mind-blowing up to 100 times faster. This is the raw power that LiteRT is designed to tap into.
And hey, even on the more traditional hardware, the gains are still pretty serious. When you're just using the GPU, LiteRT is averaging 1.4 times faster performance than the old tflite delegate. That is a significant boost in pure efficiency. Remember that whole simpler promise we talked about? This is it in action. LiteRT takes that tangled mess of NPU integration and just boils it down to 3 clean steps. You compile your model for the hardware you're targeting, you deploy it through the Play Store, and then you just let the LiteRT runtime handle everything else. It's even smart enough to fall back to the GPU or CPU if it needs to. Simple and really robust. All right, so all this speed, all this simplicity, it's all building towards the most exciting part: running powerful generative AI models like Gemma right on your device without needing a constant lifeline to the cloud. This chart is a fantastic little showdown. When you put it head-to-head against llama.cpp running the Gemma model, LiteRT just comes out faster on both the CPU and the GPU. But honestly, that's not even the real story here. The real kicker is the NPU. Yeah, that's the number to pay attention to. By using the NPU, LiteRT gets an additional 3 times performance gain on top of its already fast GPU performance. That's a massive leap. That's what makes complex on-device AI conversations and tasks actually practical for the first time. And maybe the best part of all is that developers don't have to start from square one. LiteRT already comes with this growing library of popular open-weight models that are optimized and ready to be dropped right into an app. We're talking the Gemma family, Qwen, Phi, you name it. Now, with all this new power, you might be worried that it's this complete rewrite that's going to break everything. But that's not the case. LiteRT was designed to be an evolution, not a revolution. It's all built on a super stable and familiar foundation. And you can see that clear family tree right here. It all started with TensorFlow Lite, which really set the standard for the whole industry. LiteRT was introduced in 2024, and now, today, it's fully graduated into a production-ready system with full hardware acceleration. It's been a journey of steady, reliable progress.
And here's where that flexible promise really gets delivered. Developers are not being locked into just one way of doing things. LiteRT has first-class support for PyTorch models, it continues its best-in-class support for TensorFlow, and it gives you a solid path for JAX. Basically, you can build in whatever framework you like best.
This is just incredibly smart design. LiteRT gives you two paths forward. You've got the Interpreter API, which makes sure that all your existing models still work perfectly, just like they always have. And then you have the new Compiled Model API, which is your gateway to the future, unlocking all that incredible GPU and NPU speed we just saw. So you get the best of both worlds, rock-solid stability and bleeding-edge innovation.
So, we've seen the problem, we've seen the solution, the insane performance, and the flexibility. And all of that brings us to the final and most important point. What happens now?
And this right here is the ultimate takeaway. That crazy maze of fragmentation that was holding developers back, it's gone. LiteRT provides a clear, direct path, making the full power of the hardware in our devices accessible to everyone.
So, let's just end with this question. Now that the barriers have been completely removed, now that the door to truly fast, powerful, and responsive on-device AI has been kicked wide open, what will you create first? It's pretty fascinating to think about the possibilities.